Assalamu alaikum wa rahmatullah. So I'm just going to explain to you K-maps, how it works, how you're supposed to use it and stuff, etc. So basically, this is how you draw a K-map. So if you have, let's say you have a table, okay, with let's say A and you have B, right? And we have the value F, let's say, right? And then we have like a table like this, right? And then the values are like 0 and 0, and then we have 0 and 1 and 1 0, we have 1 and 1, and then we have some values over here as well, right? So we have some values here, 0 and 1 and 1 and let's say 0 and 1. I'm just giving random examples. So then what we do is, what we like, let's say we are giving such a table that looks like this. To find the function f, to find the function f, to find this function, what we used were, we used things like minterms using the values of 1, or we used maxterms using the value of 0 and taking these values, and already you've learned how to do that. So it's like using minterms and max terms. But that the minterms and max terms, the problem with minterms and max terms is like it doesn't give you the optimal solution, right? It doesn't give you the best solution. Okay. So it gives you a solution. I think in one of the previous PDFs, the teacher gives you an example of like a function f, which is given as a long thing using minterms and max terms, but the same function is given as g, but like just like three things, three elements in an equation or something like that. So yeah, so basically we can use uh, like very smaller things to get the same function, where when you use minterms and maximums you get really long equations when you really don't need that much. Sometimes, not always, sometimes it's the same, but to make it very efficient and make very short, we use k-maps, right? So to draw a k-map, I showed you a and b. I have a's and a and b, so two variables. For two variables we use a k-map that looks what is it called, k-map, yeah, a k-map that looks like this. So there is four of them. So we have the values on the top here, these values, this 0 and 1 is for the value of b. So when b is 0 or when b is 1, this is what it means. And over here we have when a is 0 or when a is 1. And then we have these overlaps when a is 0 and b is 0. This point is when a is 0 and b is 0. This point is when a is 0 but b is 1. And this point is when a is 1 and b is 0. And this point is when a is 1 and b is 1. Both are 1 here, right? So this point is when both are 1. Got it? So that's how you look at it. So let's say we have 0 0 0 1 1 0 and 1 1. I don't know why I removed the previous one. Doesn't matter. We have f here. We have some values here. It doesn't matter what these values are. Whatever these values are, we write them exactly here, right? So we have 0 0. Whatever the value here it is, we write them here, right? So let's say there's 0. Like, let's just write the same values here. We have 0 1 0 1. So I write 0 1 0 1 basically, right? So when a and b are 0 0, I have this one 0 0. The value is 0. When a is 0 and b is 1, when a is 0, b is 1, when a is 0, b is 1, I have the value 1. That's what I wrote here. When a is 1, b is 0, 1 0, I have 0, and the last one is 1 1, I have 1. Okay, so then what happens? Now, as you can see, in this particular area, these two boxes, right, is when b is 1. The value of b is 1, right? And these two boxes, and you can see, let me just change color. And these two boxes, right, is when a is 1, right? When a is 1 is these two boxes, and when b is 1 is these two boxes, the red one, right? And this, at the same time, right, at the same time, we have the other two boxes. Like for example, when we are considering b, this is b, when we're considering b, these two boxes are when b is not, like it's when b is 0, right? So when b is 0 is these two boxes, so that means it's b naught, basically it's b naught, right? The b naught is basically when b is not, uh, that's how we think of it, right? This is b positive and this is b negative, or b naught, it's not negative, b naught, and b is 0, and this is considered b1. And the same thing applies here. When this is when a is 1 and this is when a is 0, which means this is where we consider a naught, and you'll see what I mean by a naught and blah blah blah, you'll see it now. So if we have, let's say we have values like this as given in this example over here, when we have 1 1 here, as you can see, it's the whole ones are in the spot where b is 1, like if b is 1. So this is the square, this area is where b is 1. So we have 1 1 here, so that means this whole function is b, like that's all there is, right? And as you can see, for the a spot, we have like this is in a spot, like a's box, right? When a is positive, like A spot, A is 1 basically, and this box is when A is 0. As you can see, this is when A is 0, this is when A is 1. One of the things, like we have these two values 1 and 1, one of them is when A is 1, one of them is when A is 0. So it's like A naught, it's like cancelling each other out, and we get nothing. That's the reason why in this function we don't have the value A in here, but we have the value B because the whole thing is inside B. It will become a bit more clearer sooner, inshallah. So basically the first thing what we do is we group when we get a k-map. The first thing we do is we group them, and we group them in different ways. We can group them in squares of ones, or we can group them in squares of twos, or we can group them in squares of fours, or we can group them in squares of 8 and 16 and 32 and so on. So these groups should be in the power of 2 to the power of n, right? In the value 2 to the power of n. So it cannot be for example 6. I cannot have, like, if, let's say my k-map is like this big and there are ones here, I cannot group all of these together because this is 4, this is 1, this is 2, right? 4 plus 2, this is 6. Like total is 6. 6 is not in the power of 2, so 2 to the power of n, you'll never reach 6, right? And that's the reason why we cannot group 6. So we can only group 4s, 8, 2, basically 1, 2, 4, 8, and so on, like this. Okay, and you cannot group diagonally. You can only group like this, or like this, like horizontally, vertically, or as a square, and so on. Got it? Okay. So what this grouping is and how it works and everything, you'll better understand it. But the point is, you have to group them in the maximum value, like as much. You cannot, if there is 2 like this, there is 1 and 1 here, we can group it as a 2. We have to group it as a 2. You cannot group this as separate and this as separate. And you'll understand why we're grouping and how we're grouping and what we're going to use the group for soon, inshallah. So let's say we have something like this. The question is asking, how do we find the functions, right? So we need to find the functions. So here in the first one, we cannot group anything because there are no ones. So basically the things that we group is basically ones. We group the ones, right? So we group the values of ones. So here we have zeros, there are no ones, so we can't group anything. So we just take everything and we say f, and everything is 0, everything is 0, so we just say the value of f is 0. Like whatever value of, like if a is 1, b is 1, b is 0, a is 0, whatever the value is always 0, so we have the value 0. By the way, just like I explained earlier, it's this, the k-map is drawn from a table that looks like this. Some table we have like this, and we draw the k-map based on that. Understood? So there is some table that looks like this. From that table, basically all the values in the table is 0. Basically, that's what it means. So f is 0, right? So the value function f is basically, I think you should just write like this, f equals 0. Now another one, here we can see there is 1 over here, so we can group just that one, like it's alone, the grouping is alone. Okay, so what happens then? So then what happens is we have this is as I said, this is the area of 1, this is the square of 1, right? This is the square for 1, and then we have this is the square for b, and this 1 is inside, it's neither in the a square or and neither in the b square, right? Which means the value of this is, value of the function is f equals, okay, a naught b naught. Basically I don't know, wait, I can just, so basically it's not, so it's a naught b naught, right? So it's a naught b naught because it's outside of these two squares. It's outside of a square, it's outside of b square, and therefore we get a naught b naught. I hope that's clear. Now we have this one, right? This one, we have these two ones, right? We have these two ones, we can group them together like this. We can group them together, we get this one single group. And we have to take this whole group as one thing, and we look at a, right? First we look at a, so we can say f, first we'll write f equals, what is the function? The whole thing is outside of a, right? The a square is over here, this is the a square, right? This is the a square, and the whole group is outside it, right? And so we say a naught. That's how we start. Okay, so I'm going to remove f, I'm going to write a naught. Okay, and then I look at b, right? I can see half of it, half of this group is inside b, so this is the b square, this is the b square, right? I'll just take another color. This is the square for b, and my group is the blue one. This is my group. As you can see, half of the group, this part of the group, right? This part of the group is inside the b part, and this part of the group is outside the b part, which means I don't write b. Like if it's half here, half there, I don't write it. Like I just ignore it basically. But if I have it fully inside one or fully outside one, then I write something. Is that clear? So basically, as you saw earlier, as you see here, the this whole group is outside of A completely. This is the A square is completely outside of A, and that's why we write this box to say that's where A is 1. So this is the A's area. So it's completely outside of A. That's why we write A naught, and it's half inside B and half outside B. So we don't write B, we completely ignore it, and the function becomes A naught. I hope that makes sense. Okay, the next one is very similar. It's very similar to the previous one. It's basically we have the let's start with A. We have the A square here, and this is our grouping. This is our grouping. As you can see, it's half inside A and it's half outside A, which means I ignore it. I don't write A in anything about A. A is like ignore because it's like cancelling out each other. Half is inside, half is outside, so I cancel it out each other. But when you look at B, so this is the group we have. When you look at B, it's completely outside of B. The group is completely outside of B, right? And therefore I write B not. So basically I'm saying it's not B. It's not in B. That's what you can think of it like. It's not in the square of B. That's what it means. It's not B. But the other one is like I'm in or out. I'm neither. I'm in the middle. So I don't write it at all. Right? You can either write it's A or either you can write A not. You can write it's in A or it's not in A. You cannot write it's in the middle. It's both in and out. So you don't write it. That's all. So this function becomes B not. This function, you can see as we mentioned earlier, we cannot group it diagonally. We can only group it as ones, as twos, or fours. We can group them vertically or horizontally or as squares, but we cannot group them diagonally. And therefore, we take this as one group. This is our first group. This is a second group. And now we'll come to how we separate the groups. So my function will look like we'll take the first group. Like you can order whichever you want. Let's say this is the first one and this is the second one. So we'll group them one by one. So I'll take this one first. I look at this and I look at A. So the square of A, right? The square of A's area is this one. This is A's area, right? As you can see, it's completely outside of A. This group, right? Our group, we have two groups. This is the first group and this is the second group. I'm looking at the first group alone. The first group is completely outside of A, so I write A naught. Okay? And the first group, I'm still looking at the first group, is completely inside of B, which is B. The B square is this whole square. This is the B square. It's completely inside of A. This group we have here is completely inside of A, inside of B, and therefore we write B. Is that clear? So it's outside of A completely, so we write A naught. If because it's completely inside of B, we write B. Okay, and then we have a second group, so we write OR. I'm not having space here, so I didn't write there. It's at the bottom. So basically, it's OR. I take the next group now. The next group, this is the second group. I look at it. It's completely inside of A, so I write A, and it's completely outside of B. So because this is the B group, and this here is completely outside of B, I write B naught. Okay, coming to the next one. As you can see, this is an easy one. Everything is one, no matter what. Everything is one, right? So it's basically the function is saying that this is basically always one. Like there is no option. Like there is nothing. Like no matter what, it's one. Like whatever value you put for A and whatever value you put for B, it's one. So those are the answers. As you can see, it's the same answers we have here. Okay, and now we have three variable maps. This is, by the way, this PDF that I'm using is from previous year. I don't know if it's the same or there is any difference, but I just use that one for explaining. K maps. Now we have three variable ones. Let's say so far we used A and B. There are two variables, and now I'm going to explain three variables. So when you have A, B, C, or X, Y, Z, and stuff like that. So let's say we have these values M0, M1, blah blah blah. It's been explained here. So how we write these values is important, right? So when we had two variables, we drew a square that looked like this, and we put like this, and it was simple 0, 1, 0, 1, and then we split them. We put A here and we put B here, right? We put A here and we put B here, and these values are like when A is 0 and when A is 1, and this was B is 0 and B was 1. But what if we have three values? Like where will we put them, right? So for when we have three values, what we make a square of 8, right? As you can see here, we make a square of 8. We put A on one side and we put BC on the other side, right? So if it's XYZ, we can say X on one side and YZ on the other side. Okay. So what we write is we write 0 and 1 like before. For A value, we put 0 and 1, and for BC, we put two values. So 0, 0, 0, 1, 1, 1, and 1, 0. And in this particular order, you would think it makes more sense to say 0, 0, right? 0, 1, and 1, 0, and 1, 1. Technically, this is also possible. You can also do this. It's not wrong, but it's easier to do this way for a certain reason, because if you don't do this, then the C becomes split. Okay, how does C become split? So I'll show you real quick. This is 0. I don't think you need to know this, but I'll just, maybe it's extra information, it might help you. But it's like this. So as you can see, this is A and this is BC, right? So these things over here, so this 0 is B, this 0 is B, this one is B, this one is C, B as well, but the second value is C. So as you can see here, let me just show you this one. This whole square right here in this red is the square for sorry, this is the whole A section, like we did earlier, like this B section, this is the whole B section, this is the whole A section, right? As I explained earlier, the same thing, this whole section, the whole line is the A section, right? And the B section is this whole section. So I'll just change the color. So this whole section is B because that's where B is 1. So 1 and 1, you see B is 1. But where C is 1 becomes a bit complicated to draw. Let's check. So as you can see here, this C is 1 here and C is 1 here, right? So then what you would need to do, you need to take this square here and this square here. So it's like it's split apart. It's like kind of complicated. So to break draws and to make them groups and stuff, it doesn't become easy. And that's the primary reason why we do it like this. We put this 1 1 in between so that we can group C like this directly. I hope that makes sense. We group C directly together and we can group them easier, and we still have B together, and that's the reason why we write 1 1 before 1 0 and not the other way around. But make sure you do it like this, and when you write the values from the table, make sure you take it correctly as well. So this is how you draw the diagram. And then let's say we have all these ones. This is equals to the function is 1, right? And okay, this is explaining how we can group them. So we can group them as 8 values together, all together. We can group them as 8, but we cannot group them as 6, as I explained earlier, because 6 is not a power of 2. We can group them as 2's, and we can group them as 4 like this horizontally. We can group them as 2's like this as well, outside, like it goes like this, so it's a group of 4. This is one single group of 4. We can group them like that to the sides as well. And what else? We cannot group them like this diagonally. I think that's pretty much it. And so now we have an example. We're giving an example. So we are giving this table, right? Sorry, in this table, and we need to make it into a K-map table, right? So how do we make it into a K-map table? We have these values, right? We have 0 here, we have 1 here, we have 0 0 here, and we have 0 1 here, and we have 1 1 here, and 1 0 here, right? And we have y z here, we have x here, and it's going to be simple. So 0 0 0, you should look at 0 0 0. That's 0 0 0. The value is 0, right? You can look at this one. You can look at this line here. When the value is 0 0 0, the value is 0 0 0 1. So 0 0. So it's not 0 0 0. 0 0 1. So it's 0 0 1, right? And the value is 0 0 1 is 0. So I can write 0 here. I'm just going to use this. And there is 0 1 0. So it's 0 1 0. So it's 1 0. And there the value is 1. And then you have 0 1 1. So that's this one, 0 1 1. The value is also 1. And I have 1 0 0. That's 1 0 0, right? And the value is 0. And everything else is 0. As you can see, 0 0 0. Okay. So 1 0 1. That's 1 0 1. And 1 1 0, which is 1 1 0. So 1 1 0. And you have 1 1 1, which is 1 1 1. And everything is 0. And you can see the table is written here like this. And now we need to group them, and the only grouping that we have available is this grouping over here like this, these two. And as I explained just a while ago, these will be the X grouping. So this will be the X grouping, right? This will be the grouping for X. And we have, this will be the grouping, one second, this will be the grouping for Y. This will be the grouping for Y. And let me take this one, and this will be the grouping for Z. Okay, so that's the 3 groupings we have available. And then we look at them each one by one. We take this function f equals, we see this grouping, this pink, okay, the pink one is X, the pink one is X, so pink one is X, right? And the the blue one is Y, and the green one is Z, right? Those are the three groupings we have. And yeah, so you can draw it like the teacher drew it, like this, X like this, Z like this, and Y like this. But I'm just drawing it in a clearer way here. Now we can just take this, and we can write them clearly. So you can see this grouping, we have the grouping here, the one group, the blue group. That group is completely outside of X, so I can write X naught, right? So I'll just write X naught here like this. So it's X naught, right? And that group is completely inside of Y, right? It's completely inside of Y. So the Y block is here, and this group is completely inside of Y. So I write Y as it is, and the group is half inside Y. So this part is inside Z, this part is inside Z, and this part is outside Z or Z. So we don't write it. So the function becomes X naught Y. As you can see, using minterm, this is the equation that we get, right? But using the K-map, we get a simpler equation like this. Is that clear? So we get X naught Y. Z changes but output does not change, so Z is not necessary. Okay, so, what means is whenever the value of Z, even if value of Z changes, the output doesn't change, and therefore we don't take it. Now 3K map, it's the same thing. I'm gonna take another example. I think that pretty much explains all of K map. There needs to be known. This is a four value one, four of them. If we have four variables, just extend it. So we had like something like this, right? So we have A here, and we had B here and C here. We just extend it, so we make it 4, and we make it bigger. We make it A B here, and we C D here. We have two values, 0 0 0 1 here, and 1 1, and 1 0 here. Same values go here, 0 0 0 1 1 0 and 1 1. Sorry, 1 1 and 1 0, 1 1 and 1 0, right? And then we do the same exact thing. We can group them in different ways. We can group them as all 16 together, or we cannot group like this. We cannot group in 12 because 12 is not a power of 2. We can group like this because it's 8 values together. We can group them like this. As I mentioned earlier, we have to group the biggest grouping. Like we have to make it as big as we can. So this is like, for example, if you have something like this, we have to group all of it. But if you have something like this, we should find like two groups, right? We have to find two groups. Like this is one group, this is the biggest group there is, and this is another big group, right? Or you can try to find some other grouping. This is, let's say this is 4. I think that's the biggest grouping you can do. This is one group, and this is another group. I think we can also mix groups, merge groups. I think it's going to be explained right now. We can merge groups. Let's see. We can do merge of groups. Where is it explained? Yeah, we can do merging of groups. Yeah, exactly. So we can do something like this. So we have to make as many as big as we can, and hence we can do something like this, for example. So we can take uh, let's take this one. We can do this big grouping, right? We take this one, and this big line is remaining. So we take this as a second group. You see? So that's like a second group. Hope that is clear. Let me just explain once more. So this, hold on. So this is one group, right? That's the first group, and we have this big line that's still remaining to be grouped. So we don't just group them as like this. Instead, we make them like this. So let me take another color. So we group them like this. So now we have two separate groups. You have to take them separately and find the values separately, right? Right. And you can also group like this, backwards and frontwards. I think this PDF is explained pretty much. I believe, although this is not the same PDF, I think your PDF also has all the information you need. As you can see, we can group separately. So we have this group, one group, right? And this one is already used, but we have this one standing alone. So we group it with another one that's adjacent. And then we have this standalone group as well. And to find the values, we can take this example, try to find the values. So this section is the A section, right? And this whole section is the B section, and this whole section is the C section, and this middle section is the D section, and we use those to figure out the values. So let's take this group. That's my first group. I'm going to take this as my first group, and we're going to figure out the values. So f equals, what is the value? So this section, this whole section is completely inside of my A, so I write A, right? So A is done. Now I look at B. It's completely inside of B because this is my B, right? This is my B, and this thing is completely inside of B, so I write B. And then I look at C. It's half inside C, so this is inside C, and this is not inside C, so I don't write C, I just ignore C. And I look at D, and I see it's completely inside D, so I get D. That's my first group done, right? I'm done with the first group. Now I go to the second group. So my second group, similarly, I can, and I write or, and I find that this group is completely inside of A. So I write A. It's half in B and it's half outside of B. So this part is inside B, right? So this part is inside B and this part is outside of B. So I don't write anything about B. I look at C and I see it's completely inside C. So I write C and I see it's completely inside D and I write D. And I have one more grouping remaining, right? I have one more group remaining. So I take that group now and I look at it, or I see it's completely outside of A. So this is my A section, it's completely outside. So I write A naught and it's completely outside of B. This is my section of B and it's completely outside of B. So I write B naught and it's completely outside of C. So I write C naught and it's completely inside of D. It's inside of D. So I write just D without D naught because it's inside D. As you can see, it's inside D. I hope that makes it clear. That's how we do it. So let's just to give you an example like this. Okay. Okay. Anyways, let's just do this real quick. How many? Okay. Yep. Okay. So as you can see, if you have these values like this, so we have a one here, one here, one here, one here, one here, one here. The total grouping, like the most obvious grouping that you would think you can do, would be like take this and then take this. But as mentioned earlier, we cannot do this grouping because there are six values: 1, 2, 3, 4, 5, 6. 6 is not a power of 2, so we cannot group them like that. So what we do, we first group them like this. That's one group, right? That's one group. But then the problem is we have these two remaining. So what we do is we can't just group them like this. You can group them, but it won't be the most efficient, I think. So we group them like this. We group these two and we take these two with it. So that's the second group. So the group one is these four. So this 1, 2, 3, 4. That's the first group or the second group. And this is the first group, let's say. So we have two separate groups and we are using two values in two groups, but it's fine. We can still find the values. She's giving another example. As you can see, this is another example. More examples and so on. Now she's explaining that you can use K-maps using zeros instead of ones. Earlier we did just ones, so it's like the previous one was K-maps for minterms, and this is K-maps for max terms. In a way, you can think of it like that. So let's see, we can check zeros. So this is another example. She's finding the value for it, blah blah. So now she's checking the zeros, right? So instead of grouping the ones, we group the zeros, right? So how do we group the zeros? The same method. So same method, right? So let's say we can group them. That's one grouping, right? That's another grouping, right? And we have that's another grouping, and we have another grouping like this. There is a grouping like this, I think. Maybe that's not the most efficient one. Maybe there is better ones. Let's look at what the teacher did. Okay, so this is what she made this group here, that's one group here like this, and there is this group, and then there is this group. So the group, yeah, okay, basically what I did, except I had an extra group which is unnecessary. I had an extra group over here like this, which is unnecessary because that was used in all other groups. Okay, this is the grouping that she's using, and we have this group. So there are how many groups? It's 1, 2, and 3 groups. 3 groups. I had 4 groups. 3 groups is fine. 4 groups is also fine, but won't be the most minimal one. We need the most minimal one. That's what we are doing. So then what do? We basically do the same thing, but kind of in an opposite way. So for this, what we do is basically we group them like this. We already group them. We group them the same method. The grouping method is the same. The only difference is that when we write the value, we write f not equals. So earlier when we were using the one values, we are checking once, right? We used f directly equals whatever the value it is. But now we write f not equals whatever the value we get. We use zeros and we do the same thing, right? And we get what is it? One second. Yeah. So we write f naught, right? We write f naught and not directly f. So let's do this step by step. So let's take this group first, right? We're going to take this group first, this one here, and we can see first look at A. It's half inside A. This part is inside A, right? this part is inside A, and the rest, this part, the other half is outside A, right? So we don't write A, we completely ignore it, right? And so we don't write A. So the next one, so I'm going to write it here, F naught equals, so I don't write A, I'm using this group now. And I look at B, the same thing, right? So this part is inside B, and the other half, this one and this one, is outside B, so I don't write B. When I look at C, it's fully inside C, okay? So I write C, and when I look at D, it's also fully inside D, so I write D. That's one group done, right? So that's one group done. So now let's look at the second group. So now I have this another group. That's, as you can see, it's fully inside A. So I write A, and it's fully inside B, so it's fully inside B. So I write B, and should probably use a better color. Let's just use C, D, A, B, B, or I'm not typing because I don't know how to type this D thingy. All right. So now we have we did this group and we did this group. We have this group remaining, so we have this group over here, right? So we take that group and you can see it's half inside. So we're looking at A right now, so it's half inside A. So this part is inside A, this part is inside A, and this part is outside A. So it's half inside A and half outside A, so we don't write A. And now we look at B, it's fully inside B, right? It's fully inside B, so we write or B, that's the third group, right? Or B. And we look at C, and you can see that it's half inside C and half outside C. How is that? So this part is inside C and this part is outside C, so we don't write C. And we can see it is completely outside of D because this is the D section, and this group and this group is fully outside D, so we need to write D naught. So we write D naught, okay? And that's how it works. That's the whole equation we have. So F equals CD or AB or BD naught. And I think that's the same equation we have here. It's just a different ordering, but AB, BD naught, BD naught, CD, CD. Okay, I think that's pretty much it for K-maps. There's nothing more. And basically, yeah, okay, I just forgot to mention. Basically, this gives us F naught, right? This gives us F naught while you're using the zero values. To get the function f itself, we just need to put a naught on top of it. We do the whole naught, and we use the, what is it called, the De Morgan's law. We use De Morgan's law, and we find the value of f. Basically, we find this formula for f.